Before we can talk about operations with polynomials, we first have to talk about some properties of exponents so that you can perform the operations of the polynomials, okay? So this is going to be a review for a lot of you, but some of you may not have seen this before, okay? There are 7 exponent properties. Have y'all seen them? Have y'all talked about these before? Some of you saying yes, some of you saying no. I think when you see them, you might say, hey, I remember that. All right, I think I'm going to lay it out like this. They're really easy as you look at them, but for whatever reason, when we go and put them all together, students struggle. Oh, I'm saying I don't understand why. They're pretty straightforward. I've never understood why this was a struggle, but it is. So we'll take some time to talk about it and look at it. All right. The first one, and I'm not going to make you remember the names of them. If you want, I'm going to put the names up here so that you have nice organized notes, but I'm not going to say, hey, what is the product of powers? I just want you to be able to do it. Okay. All right. Here's what it means. Product means multiply, right? Yes. What does power mean? Exponent, okay? So if I have 2 things that are being multiplied together, okay, the key here is that the base, what's the base? X, right? The base has to be the same for these. That is crucial. This only works if the base is the same, so you might want to write that. Same base. If that's the case, and I am multiplying, then I can simplify this very easily. Do you know how? You add. You keep the base the same, and you add the exponents. So y'all have seen this before.
No.
Chemistry? So if this was x to the 3rd, y to the 2nd, x to the 5th, how might that simplify?
Okay.
You can only combine the ones that have the same base. That's exactly right. And I add those exponents together. Does that make sense? Do you see that the base itself is not being manipulated?
Yes.
So if I changed it to 2 to the 3rd times 2 to the 7th. Exactly. Don't multiply. That's a common mistake. Leave the base alone when you add those exponents, okay? That doesn't become 4 to the 10th. You're changing what it is then at that point. Does that make sense to everybody? Product of powers. All right. I told you they're easy on their own, but when we put the 7 together, then you'll kind of go, what? All right, let's look at number 2. 7. Number 2, we did product of power, so now we'll do quotient of power. Quotient means what? Division, divide. But you're actually on the right track. You're just ahead of everybody else. Again, same base is the only time this works, okay? Let's say I have x to the, we'll do it in general first, and then we'll do some examples over x to the b, because these are the same base, okay? And Connor was exactly right whenever he said subtract. If you think about when we multiply, we add the exponents. The opposite of multiply is divide. The opposite of add is, so I subtract the exponents. So this becomes a minus b. Again, the base has to be the same when you do this. You can't just do it all willy-nilly on any one you want, right? Both. Both. Okay, so that's a very good question. So if I had, let's say, 3x squared over, let's make this 12, x to the 5th. The 3 is its own piece. So the question was, does that mean that they have separate bases? Well, actually, the 3 is a piece on its own, and the x is a piece on its own. So it doesn't move with it. It doesn't stick with that. The only way that it would be part of the base is if you did this. Now the base is 3x. But the way it sits here, you've got one term that's a 3, and then you've got that x to to the 12th, and that's the base there. So how might that simplify? Okay, so if it was
3 over 5, or 3x 12 5x. It would still be
what do you think happens?
3 over.
What if the bigger number was on the bottom?
Ooh, we're going to talk about that in just a second. Good question,
On
though.
the bottom?
It would stay on the bottom, yeah, but we're going to talk about why. Yeah. It would. Y'all are jumping way ahead. That's good, though. Stop. All right, y'all got that one? Again, if there's numbers in there, did you say no? Such a jokester.
You're so silly.
Is this negative x?
No, this is the same thing. How might that simplify? You're going to get just the like terms together, right? What does that become? 2 squared? How do you know it's x squared? I don't see an exponent here. It's a 1. That's exactly right. Does that make sense to everybody?
Mm-hmm. So what are we going to do with like that?
What?
What are we going to do with the 2 squares?
It's simplified. That's the simplified version.
So that's like as far as
We're going to be working with polynomials, and they'll have different exponents and stuff, and you'll have to know what to do with them. Just to show you one that combines the first two properties, what if I had it's got actually both of them in here. Now I want you to look at something for just a minute. I kind of threw these parentheses in here to intentionally throw you off. Are they really? Should we distribute? Why should we not? It's still multiplying. There's no other operation here but multiplication. So you don't have to distribute. So they're just there kind of throwing you off, but you'll see that a lot, okay? So this is, because all I'm doing is, now if I had a plus in here, or a minus, I would need to distribute through, okay? But because I don't, no, there's no need to distribute here. So, tell me what you think I can do.
Add 3x. X 3.
Look up top, exactly, exactly. Look at what has the same base, and go ahead and get those together. 3, 2, x, what does this become? And I'm over, what happens on the bottom? What's it look like?
It's going to be 3x.
That's exactly right.
We're going to end up with 3, 2, x 4.
3, 2? Just 3. X 4. Ooh. Why? Let me leave it -3, and then we'll get to the next property. But you're right, Eliza. You're absolutely right. So this leads us up very nicely to the next property, which is, well, I'm glad that's also the next property in your book. Look at there. The negative exponent property, yes. Negative exponent. And y'all have kind of already figured this out. But what it says is if I have this base with a negative exponent on it, all it does is it becomes positive and it moves. Okay? If it starts in the top negative, it moves down to the bottom and becomes positive. If it starts in the bottom negative, okay, anytime it crosses the fraction line, it changes signs, essentially, is what it's doing, okay? If it crosses down, it changes signs. If it crosses up, it changes signs. Okay, so what we ended up with just now, what was that final one? 3?
X4, Y minus 3.
This was,
4 over 1.
yes.
But if it was just like y minus 3, then it'd just be 1 over.
Yes, yeah, yeah. Because if there's nothing there already, you hold the place with a 1. How about this one? What would that become?
5.
Y
Five.
over
Y over X.
5.
Good job, y'all. And I say that because you knew not to move the 5 with the X. You recognized it being a separate piece, which is really good. Okay. All right, everybody okay so far?
Yeah.
That's 3. We got 7. Almost halfway there. Number 4. Y'all are so quiet today. I mean, I'm not complaining or anything. I'm just, y'all are awful quiet. I know, that's why I said I'm not gonna complain. It's just strange. I think too, because the air conditioning's not running. You're hot? Well, this side of the room's hot. If you sit over there, it's... All right. All right, power of a power means I have a base that has a power, and I'm raising it to another power. Okay? Remember, exactly. Remember, whenever I'm multiplying and the bases are the same, I add the exponent. Now, whenever I have a power raised to another power, I multiply. So I do A times B. This is a pretty easy
So
one.
say if it's like 2xa equals b, be 2b.
Say it again.
If it was 2xa in parentheses, like the whole thing, b, it would be 2bxab.
Yes, and you just jumped ahead to another property too. Look at you. Yes, yes, yes.
Okay,
Okay. Let's.
First lesson of the chapter.
Yeah. Well, I don't want you to put it. We haven't got to that property yet. I'm sorry. It's 2bxab.
But it'd be like 2 power.
It goes to both of them. It goes to both of them. Yes, but that's another property. But yeah.
I mean, but if it's just a variable, like if
But
it's
do you
X,
distribute 2?
Okay, so if it's just x, like it was 3 to the 5th, that would become x to the.
So just base.
okay, but if it was like 2x to the third, then it'd be 2 to the 5th, x to the 15th.
Yeah. That's the next property.
Why does it usually be one opposite?
Why what?
Why is it just one opposite? They kind of go along.
They kind of do, but then again, they're separate. They do and they don't.
Is it going to be specific about which property?
No, like I'm not gonna say
Use solve the y problem?
right. That's why I said you don't really have to know their names as much as know what they do and when to do it. Like I'm not gonna say. Some of my other classes, when we're just learning and I feel like they don't have a good handle on it, a lot of times I will have them one step at a time list the property that you use beside it. And not so much that I want them to memorize the name of the property, but I want to make sure that they're using a justified valid property for each step along the way. But the name of them's not so important, no. I've never been stopped and said, what's the power of a power? All right, what number are we on? Numero 5. This is what y'all keep wanting to do. Now, this is a dangerous one, and I will tell you why in just a second. All right, we did product of a power. That's where we multiply with same base, different powers. But this is power of a product, okay? So it means I'm multiplying together, so maybe x times y, and I'm raising this to an exponent, okay? Now, when you do this, and several of you have already said, I can distribute this exponent in here, and you are absolutely right. Why might I have said this was a dangerous property?
Because you could multiply that and then times the
And then
power.
if it doesn't have parentheses, you might start doing.
Then you get big
You
numbers.
might do PIMDOS wrong.
There's a number.
For set mass.
You might just forget and just do the a to the y.
There's another number
Yeah.
in it. There's another number in parentheses, you might know.
Well, there's a negative exponent.
Oh,
Because
Then you have to do.
Then you'd have to distribute and add.
What if
That's
there's
dangerous.
What if there's already a power?
If you are adding or subtracting in those parentheses, you never, 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 never distribute an exponent.
So what do you do? Cause if it's like.
You're gonna add first and then exponent.
Yes, and if you can't, then it becomes a FOIL type problem. Okay? So in other words, why does it keep doing that? Look!
What?
Look!
Time is suspended.
Hit it.
See, it's telling you. I'm telling you can't do it, and it's saying, no, never do that. If you have... Okay, I just went to another page. Let's see. If I had x plus 3 to the second, just to show you that that does not equal x squared plus 3 squared. Okay? You don't have to, I'm just demonstrating. This tells you how many times to multiply that together, because it's the definition of an exponent, right? If you got a 3, that's saying multiply together 3 times. Think about 3 to the second power. That means take 3 and multiply it 2 times, right? Are y'all following me? Okay. So if this is saying x plus 3 to the second, it's saying take x plus 3. I am really struggling with this board today. Which means now I have to start distributing. X times x is x squared. Mm-hmm.
So then if like the exponent's 3, you would FOIL that and multiply it by.
Plus 3x plus 9. It does make a perfect square trinomial.
It'd be x squared plus 6x.
Yes. Is that the same thing as x squared plus 9?
Yes.
Is that the same as x squared plus 9? No. Well, this up top, x squared plus 3 squared. The point that I'm getting to is these are not the same. Okay, you get something different. That's why it doesn't work. But if I was multiplying those parentheses, so if I had 3 times x squared, and I use that property, 3 squared, x squared, right? Is it the same? Well, 3x times 3x, 3 times 3 is 9, or I can use that exponent property with the same base. 3 squared, x times x is x squared. So it does work if you're multiplying, but not if you're adding or subtracting. So always, and I intentionally took a long time going through that, and I know that y'all think you know that, but inevitably somebody is going to do that at some point. You're going to distribute. All right, let's keep it moving on. What number are we on?
6.
Number 6. Woo, we're almost done. Power of a quotient. If you can remember power of a product, you can remember power of a quotient, because power of a product is multiply, power of a quotient is
Subtracting.
Yeah.
dividing. I was so excited too. All right, so same concept here. If you are dividing inside the parentheses, then yes, you may distribute that exponent. What happens if there's already an exponent on it whenever you go to distribute? Multiply, because it would be a power raised to a power. Okay. One more, and then we're going to do several examples to bring everything together before we talk about polynomials. Look at this. What if it was x plus 3 over y raised to some power, maybe 2? You could, yeah, so you would have to do this, x plus 3 squared over y squared.
Or would you want us to like do the 2 x plus 3 x plus 3?
Not here.
Distribute it and then put it on the
Mason, can
side?
you like move
Not
your
yet.
neck down?
Not yet.
Stop being mean.
All right.
There was a negative one.
Same thing. It's still the same property. So if I had like x negative 3 over y 2 raised to the 5th, or even if that was negative 5. Same thing. So the nice thing about properties of exponent is there's not an order that you have to, you know how we have to simplify PEMDAS, we have to solve SADMAP. This, as long as you use a valid property every time, there's not a particular order that we have to do it in. So here, this becomes x, negative times a negative is a positive. Now, if you had moved that x around first, that's fine too. Again, it doesn't matter as long as each property that you're doing is valid, okay? So now I did the negative exponent property and moved it up.
Think about like actually -1.5.
You can. Last property is the easiest property. It's called the zero power property.
Zero.
Anything to the zero power.
Equals 1.
It's always 1, as long as the base is not 0. Anything to the zero power is
So
1.
0 to the 0 power is 0?
Yeah, that's fine.
Or 0 to the 0 power.
What happens if the base is
Put it in calculator, see.
My calculator is messed up.
Zero times zero.
When I do a negative number squared,
It says
gives me a
error
negative
domain.
Mmm.
Wait, Miss Vicky, can you fix my calculator?
0, 4.
It's far enough. Where-
Let me do a couple of examples.
Calculator's only as smart as it's used.
Ooh.
My calculator's stupid.
Now listen, that's not true.
Okay.
Keep talking.
Alrighty.
All right, simplify. Sure. Any properties in any order. So some of you want a chance to do it on your own, and that's fine. I'll just give you a couple hints as you look at it. Think about things you can do, okay? Same bases when you're multiplying. You could do that first. You can move negative exponents first. I would drop the parentheses first and look at it. Whatever you want to do is okay. But remember, all this is multiplying, bless you.
I'm just gonna watch you do it.
All right. Oh, there are no like bases. Oh, A. I see it now. I see it now. Okay. All right. So looking here, is that what y'all did first? Yeah?
Wait, if it's 2 and 3, do you add?
Multiplying. You're still multiplying. Okay. 2 times 3 is... And if you left it as 2 times 3, technically while we're doing exponents, that's okay too. They're so little though, I might go ahead and do that. What do the A's become? Just A, right? Because negative 2 plus 3 is 1.
That color is
White?
that's white.
It looks blue.
White.
This is okay.
Y'all! This is like that, is it blue or is it white meme. It's definitely white.
It looks white with my glasses. But if I like look over on
It's almost like a snow. I put it over C's.
All right, that's exactly right, Meg. You're exactly right. I have a negative exponent, so I need to bring that down.
You should have 2 negative exponents.
Where'd you have another one?
A negative 2 times A.
Well, I combined the A negative 2 and the A 3 to start with.
You like,
You add them.
I added the exponents together. So negative 2 plus 3 would be 1.
Whoa.
Now, if you didn't and you moved it, that's okay. You'd come back to the same answer in the end.
I'm multiplied this.
Multiply it by what? Well, when you're multiplying, you have to add exponents. All right, let's look at another one.
Both of the exponents are inside of the parentheses. You only multiply when an exponent is outside of the parentheses.
Simplify, and I'll give you just a second to look at it. Aight.
Yeah. Okay, so. I don't even know this one.
You don't know this one?
No, it's
No.
not.
Oh. I'm writing slow. Don't look up until you're finished. Yay!
have a question. Do we?
If you put if you put 8, that's okay too for 2 to the third. Okay. Just making sure that it goes to all the pieces there. All right, let's do one with even more properties.
Oh, yeah. See one with all.
Do one with one like that.
I
inside.
don't know what I love. Well, you know.
Y'all ready for this?
Probably not.
Oh, buddy.
Make my house hurt. Not gonna lie, that was good. I'll give you a 6 on that one.
Yes. As you're finishing up, several questions came up about what you have to do first, and again, it's up to you, okay? I would simplify inside first because I'm just accustomed to simplifying in parentheses first. I subtracted the c's and got c to the third.
We can divide the 2 numbers.
15 divided by -3.
Oh,
D -4.
But does it have to go on the bottom?
It does because it's a negative exponent. So I would do
I mean, that's really
negative.
bad.
Where you go?
Oh, you have to, subtract. It's.
Is that supposed to be negative? What did you do?
All right, where are y'all confused? Tell me where you're.
Oh, I'm sorry.
-5.
The -5 are these two divided. Don't forget about basic fraction rules, right?
But could you just like wait to do that?
Sure.
I did the
Yeah,
square
that's what I did.
first.
yeah, I did this.
So if you do that, then you got 15 squared divided by -3 squared.
Yes.
Well, you'll get.
And it'll reduce down. You're just working with bigger numbers. For mine, see, I'm going to come here now. Again, there's no order for this. As long as you follow valid properties every time. -5 squared is 25. C to the 6th over D to the 8th.
Wait.
So
So,
then I'll go.
wait a minute, speaking, can you scroll up?
Yeah.
So, it was D to the -4, so that would be on the bottom.
So it moved down and became positive, right?
Right. So then it was,
Wait, I have a question.
okay.
Okay?
So I messed up, so I already put it on the bottom as a negative. So it should.
So when you subtract, always stay in the top, and then if you get a negative, then move it. But even if you get a negative when you subtract, keep it in the top, and then move it down and become
That
positive.
makes sense.
So
It's a common mistake,
I
though.
like had everything until the 25. Since I did the square first, I ended up with 15 squared over -3 squared.
Which
So
is,
when I divided those, I thought you got rid of the square because 2 minus 2 is 0.
so you got negative, or you got,
It was
15 squared over -3 squared. So that would be, what is that, 225 over 9?
Oh, I was.
Okay, so can you show us how you do it?
I didn't square it.
Square it before you simplify it?
Sure.
Got rid of the square.
'Cause that's what I did at first.
So if you squared it first, you would end up with 15 squared C10 D6 over -3 squared C4 D7. So this is 225 over 9.
With the D4 together.
Oh, yeah, sorry. This would be 10 minus 4 is 6. 6 minus 14, -8. This becomes 25 C6 D8.
That makes sense.
So if you do that,
I like the way you do it.
Well, but I've done these so many times I know what to do first. You know what I'm saying? But I like to do them the way, whenever you say, hey, I did this, and show you, it still comes out to be the same thing. So you don't have to do it the way I do it. You know, you see what I'm saying? I can just look at it and know what I need to do first because I've done them so many times. But Now we gotta do polynomials. All right. But y'all, it'll be okay. All right, so polynomials, first I need to tell you what a polynomial is, right? So a polynomial is made up of terms, but those terms have to be special. Let's see. Let me give you an example of a term. 5x to the third power is a term, okay? The 5 in front is a, do you know what it's called?
Coefficient.
Yes. Three is the power or the exponent, okay? For a polynomial, all the terms must have positive whole number powers, okay? Only the one that's hooked to the x. The coefficient does not matter. Now, the coefficient needs to be a real number. If this was 5i, it wouldn't work, okay? But other than that, we're mainly looking at that exponent. Is it a positive real number? When we line up polynomials, we line them up from greatest exponent to smallest exponent, okay? That is standard form. Standard. Biggest exponent to smallest. And we do this because whenever we analyze these polynomials, when it's in standard form, we can get a lot of information from it.
What do you mean by like biggest?
X to the fifth and y.
Right. So let's say I have that is pi. My first question to you is this a polynomial?
Yes. No.
Why?
No. Yes.
You're not going to have a lot. This is just
Pi isn't a real number.
a really wacky example to show you. Just, I'm kind of reiterating the definitions here.
Pi's not a whole number.
What has to be whole numbers, though?
Your coefficient.
Ah, reading green again.
Positive.
The powers have to be positive whole numbers.
Yes.
The coefficients just have to be, are all the coefficients real numbers?
Pi is a number.
Pi is irrational, but irrational, woo, irrational is still real, right? We're really just eliminating our imaginary terms there. All right, and all the exponents are positive whole numbers, so yes, this is a polynomial. It is quite a wacky, nasty polynomial, but it's a polynomial
So all we have to
nonetheless.
do is say if it's a polynomial or not?
That would be nice, wouldn't it, Marshall?
Yes.
So the coefficient just can't have imaginary numbers in it?
I love y'all, that's why I teach y'all, so. What?
So coefficient just doesn't have to have an I?
I think Marvel's just not thinks the dumbest question.
Is this polynomial, since we have determined that it is a polynomial, is it in standard form? Why?
Biggest and smallest.
Biggest exponent down to smallest, right? When it's in standard form, okay, it's got to be in standard form for what I'm fixing to tell you. This exponent is called the degree.
The biggest one is called the degree.
Okay, yep, we'll put that in parentheses. Biggest exponent. So this is a polynomial of degree 5. The number in front, or the coefficient that is hooked to the degree term, is called, does anybody know what it's called, by the way?
Well, the bystander.
Okay, I'm just going to tell you.
The leader.
Leading coefficient, does it make sense why it would be called the leading coefficient? In standard form, it leads the equation. It's in front.
What is just x now?
1. No, we won't do that. Anybody know what that's called? That was a great answer. It is a y-intercept, actually. That's a great answer. Give me another word that starts with C. Not caboose.
How do you say caboose?
I know. I said another word that starts with C. What do you call a value that doesn't ever change? It doesn't have a variable hook to it. Constant.
Oh my god.
So the number at the end is called constant.
Yes. Okay. Remember, this is whenever it's in standard form. All right, so those are just the pieces. That's not actually what we're doing.
Every math question had
There
constant.
was like
Every
literally
one.
7 questions about like.
And y'all didn't know what it was?
I thought it was a number that never changed.
It is an
It is.
I mean, I assumed that.
Okay. The good thing about Algebra 2 is there is so much Algebra 2 on tests like that.
That's the good thing about it.
That you're learning it for it.
I'm taking the real SAT.
And it will definitely, this class will definitely. Yeah.
I'm gonna forget all I'm gonna forget all of this by now.
No, you won't.
Yeah, you probably will.
Okay, so 5
keep going.
is like 5, the leading coefficient, and a constant.
Yes. Well, no, it doesn't have a constant. The constant would be 0. Did y'all hear the question? If this was the polynomial, and that on its own is a polynomial, it doesn't. There's no minimum number of terms. The leading coefficient would be 5, the degree would be 3, and the constant would be 0 since there's not one there. It's like your C in your standard form of a quadratic equation. Okay. All right, let's talk about the operations we're going to do with them. Addition, subtraction is super easy. Then we're going to do multiplication. It's a little bit harder, and we save division for tomorrow.
Wait, say again?
We're going to do addition, subtraction. That's really easy with polynomials. Then we're going to do multiplication. It's a little bit harder. We'll save division for
So
tomorrow.
our homework be on both the 7 things that we just learned and this, or just the?
Yes.
Or just the 7?
All right. I'm almost done, guys. Y'all, well, okay. We still got a little bit to go. Let's.
Teasing us with the game.
Okay, addition, subtraction.
Take a moment.
I don't know. I was like, I'm almost done, but I don't want to lie to you and say I'm almost done. I still have multiplication after this.
Like when polynomials, we have 2 slides and have 8.
Yeah. Yeah, start doing this period after.
We're almost done.
This is really not hard, though, this addition, subtraction. I'm going to show you one example. If I need another one, I'll do it. I think you'll be okay with one. So addition and subtraction are essentially the same thing.
This is gonna be a long video.
That's exactly what I do. You're exactly right, Livy. All right, look.
You have to distribute the negative.
Yes. If you're subtracting, you have to distribute the negative before you change. Okay, but after you do that, this is just a combine like terms. Do we all know what like terms are? Same what?
Same but different.
What's the same? Somebody, same base and power. Same base and power makes like terms, right? All right. Combine like terms. All right, I'm going to go ahead and distribute this negative through to everybody. It goes to everybody in the parentheses that follows it, okay? Now just gather your like terms together.
Wait,
Okay.
but if they're all negative, so let's put them on the top.
Not exponents. You're thinking exponents. And we're gonna-
We distribute it to the coefficient.
To the coefficients. That's exactly right. All right. Do I have another squared term? Yes. 4x squared and negative 2x squared. Give me. I'm done with those. That's exactly right. Negative 8x. It is super easy. I'm glad y'all think so too. Addition, subtraction is super easy. I do want to spend a little bit of time on multiplication.
It's like what you do with imaginary numbers. The I.
Yes. Okay, so. Division's tomorrow. It's long.
Isn't it like the same thing?
No, not if she's doing it. If she's doing a whole same
It's like,
Ah, you're making me write division.
And it's just when you're.
We're going to do a long division, and we're going to do a...
This is the part that Gracie said.
All right, multiplication. This is why I don't like the term FOIL. Because if you learn it FOIL, then you're not really learning... If you don't learn it FOIL, if you learn it distribute, then you can multiply any polynomial together, right? It doesn't matter if it's 2 pieces and 2 pieces, it could be 5 pieces and 3 pieces, as long as you know how to multiply it together. It's not like I'm ordering chicken. Okay.
Oh,
Ordering what?
3 piece.
Chicken.
Every piece to every other piece. Does that make sense?
Here's what you do, and it does make sense when you do it. When you are multiplying, this is just a big distribution problem, okay? Every term in the first polynomial has to multiply to every term in the second polynomial.
Well, what's the word after 2? After 2.
Multiply. So I generally just start, and I literally still do this. I know this is probably like elementary, but I still do it. I will circle the term that I'm working on, and I will literally distribute it through. That's fine. If you put the x minus 4 in front, it might make more sense to you, and then you can distribute. But just to show you, I mean, it doesn't matter. You can do it either way. X squared times x is what, Connor?
It is, x to the third.
Mm-hmm. X squared times negative 4.
Negative 4x.
I'll go from the hospital.
I'm sorry. Oh my God. That was a jerk thing to say. That's why I said we can do it. It's not hard. It just takes a while. All right, so I'm done with this one, right? It multiplied to everything. I mark it out. I'm telling y'all, I literally do this even now whenever I multiply these, so I don't lose track of what I'm doing. Now I go to the next one. Now it multiplies through 4x times x.
4x squared.
See these exponent properties coming into play?
We're gonna
It looks like half of this problem cancels.
Yeah, it does.
It might. Minus, this one's done.
Wait, 16. We're done.
The two
Yes,
sixteens
sir.
cancel each other.
Plus 16x
Minus 60.
minus 64. Oh, this is a difference of 2 cubes, that's why.
What does that even mean? Those two cancel.
You're gonna learn it, don't you worry, my little
Is that
friend.
when you just,
It just
the,
means like
one of the one is plus and then the other one is minus, x minus 6x plus 6.
Is there any way to...
This is difference of 2 cubes. It's a little different. It's a special pattern. We'll learn about it. All right.
Is there any way to, like, skip all that?
Nope.
Just, like, it's not like a shortcut.
Nope.
Like, look at that.
Nah.
There is one, it's just on one
Four
side.
times six.
There is one, isn't there?
there is one.
There is
It's
one.
84.
Shortcut, Phyllis.
No,
It's 64.
It's 64. Because 4 to the third power is 64.
That is literally a perfect
All right.
square and the factored version.
They're actually both perfect cubes.
Yeah, because x minus.
All right, listen. I need to show you this too. If you have ones that are, because this is in your homework, 3 pieces, or actually, I said it's supposed to be a y, it's okay. If you have more than 2 pieces, don't multiply more than 2 at a time. Okay? So multiply the first 2, simplify it, and then take it to the third. So go ahead and multiply those first 2 binomials out and tell me what you get.
X squared.
Quiet, Marshall.
Well, I was right. Come on, Dave.
I am trying to do this one.
He's trying to do it on his own, and you're giving the answer. This is nice and easy because the middle terms. Oh, it's awful. Are you tired of watching me banging on the podium?
Do it, keep on doing it.
Keep on doing the problem?
No, the pulpit thing.
Oh. You called it a pulpit. Like I'm a preacher?
Isn't it like the
Preaching
name
how
of that thing?
disappointed you are.
I don't know. You know that's what we call it at church, but I don't know that I call it a podium.
It's a podium if it's anywhere else, but it's a pulpit.
Is it? I don't know. Is that true?
Well,
I rule.
All right, I'm still multiplying here. Are y'all still multiplying? Marshall, come on.
y'all talking.
Maybe 2x.
He can't get his constellation.
Marshall, use the brain, they have them done.
This is nice because there's no like terms in the end for me to gather up.
Let me see.
What's it?
So we're done.
Due to the